All right, so in these first 4 sections, I have 18 slides that we're going to get through here in a relatively short amount of time. But quick reminder, the other time when we met, I talked about some of these things. A Cartesian coordinate system, that's just an XY axis. Right? An XY axis, that's a Cartesian coordinate system. There are other coordinate systems. Polar coordinate system is one that you may get to if you take pre-calc. They have ordered pairs because we have an X and a Y. So anything that's in here, this particular point has an X1, comma, Y1. I'm just calling it 1 because it's the first point I wrote. But each point has an ordered pair because that tells you its exact location. If you're ever working on maps, reading actual maps where you have longitude and latitude, it's a giant Cartesian coordinate system. Now it's actually on a curved surface, which makes it more complicated, but it's still a Cartesian coordinate system. And they have different things that we'll cover here quickly. Today we talk about forms of lines, standard, point, slope, slope-intercept. Graphing, we're talking about slope and intercepts. We did a little bit of that the last time we met. We're going to talk about functions, what it means to be a function, domain and range. And again, hopefully these words are going, okay, these sound like I think I've heard this before. We'll dive into a little bit more so you remember what they are. Vertical and horizontal lines, and then what it means to be perpendicular and parallel as we go along. So if you have a computer or a phone that has Desmos, I would encourage you to open that now because we're going to go through a couple things quick. So when you get to desmos.com, and again, if you have a smartphone or a tablet or something like that, you can actually download the app. So that way you're not always going online to use bandwidth, things like that. But if you don't have a lot of space on your phone, then you might not want to do it. But that's what it looks like. In here is where you type the equation. Here's where it does the graph. Down below are the basic functions I have. And you can actually expand this out and do a lot of trig, you can do stats, you can do pre-calc, you can do a lot of different things as you get going into this. This would be if you're going to take something and square it or to a certain power. So this will get us there. There's my absolute value function, which we're going to use today as well. So on the left-hand side there, I've got 3 different things. If you can, why don't you recreate all, I got 4 of those. Recreate all 4 of those. That first one up there, if you just go parenthesis 2, comma 3, it'll make then a point and graph it over here. When we're in here, and it would graph that point right over here at 2, comma 3, 2 over 3 up on this graph. There's my attempt at using my finger. I should use my pen instead. 2, comma 3. All right. Recall certain other things. Like this is the first quadrant. My pen. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. Just in terms of remembering when we're graphing things, what these different parts and pieces are called. Although it's not labeled here, I will label that with X. I will label this with Y. Because anytime I do a graph, I always label X and Y. I have some points on there. I'll label the points so I can see them. But if you graphed these other things as well, you'll get a couple shapes. This first one, when you graph it, what kind of a shape is it? So that first one is a line. It's linear. The y-intercept is -3 as I point at it right there. So if I go to -3, -3 is right here. That's the y-intercept. My slope is 2/3. That's the number in front of the x. Recall y equals mx plus b. So that means I'm going to go up 2, 1, 2. I'll show it like this. I start here, I'm going to go up 2, 1, 2. I'm going to go to the right 3, 1, 2, 3. And I'll put that point there. Got to be careful on my graphs to know every one of those little boxes does not mean 1. You have to look at your labels. That's 2, which means 1 is halfway between, so it's actually 2 blocks up. All right? Straight line going through like this. Then I have this equation. What shape is that equation? Did anybody graph it? I see some graphs there that have it on there. It's a curve. you remember what type of name that curve has? Parabola. It'll go through 1, 1. It'll go through 2, 4, negative 2, 4. I missed my points there a little bit, but looks something like that. It's a parabola. And then the third one down there is also a line. It just is in a different format. That's in standard format. If I ever ask you to graph some work and then send it to me or upload it as an assignment, you would take this and you would choose to export it using that symbol right there, which is no different than anything else, where you can either share the link or you can export the image. That's usually what you'd want to do. Or if you're ever doing work and you're like, I need to use this in a project that I'm using. So for example, if you ever take a psychology class, you have to do anything else, you might be doing some analysis of data. If they ask you to graph something and put that in your work that you're using, you can export the image, and then you can take that image and insert it into an assignment that you're doing for either a math teacher or some other teacher in the future. So again, great tool. You can do all sorts of different things with the size, how it's set up. I just did a 10 by 10 grid. You can set it up and have all sorts of other setups for downloading that. It's a PNG file, which means it'll have a transparent background, which makes it nice to put into papers and documents and things like that if you ever have to upload or download an image into something. All right, so now, reminder, we already talked about this one. Slope-intercept form, y equals mx plus b. And we remembered, oh yes, b is the y-intercept. That's where it intersects the y-axis. M is the slope. Typically, we talk about slope when we say words like rise over run. If you take a more sciencey class, they'll say it's delta y over delta x. Those are not great deltas, but it's like this. It's a triangle. That's delta, the Greek letter delta. It means change in y over change in x, rise over one, run. Sometimes you'll have the equation y2 minus y1 over x2 minus x1. All right. Point slope is just another form, and it would be y minus y1 equals m times x minus x1. I would use this form if someone gave me the slope and told me it goes through a certain point, and that would be the x1, y1. So if they say, oh, the slope is 3 and it goes through point 28, I would put the 2 in for x because that's the x coordinate, put the 8 in for the y coordinate. I put the, whatever I said the slope was, 3, I think. Standard form, slightly different yet, ax plus by equals c. So on that previous slide when we showed on Desmos, I had something like 3x minus 2y equals a number. That's just standard form. It's just another form. Unless I ever specify, I don't care which one you use. If you use slope-intercept, great. If you use point slope, fine. If you use standard, that's okay with me too. Do I have to memorize all of these? No. For each exam, I'll be telling you as it increments and gets larger throughout the year, a larger size, either half sheet, note card, full sheet, final exam, I think it's full sheet front and back of anything you want on it. And by anything, I mean anything. You want to have example problems, put example problems on there. Definitions, have definitions. Everybody struggles differently. Some people are like, definitions, that's not a problem. Words, I'm fine with. It's then, I think someone said the formulas. I can't remember all the formulas. Put them all on there. Write them all down, have some words explaining what's going on. Use that. My goal in this whole entire class is see growth towards understanding and be able to articulate and do the complex math that's involved. All right. In the world that we live, everything is at your fingertips. So if you're like, I can't remember the slope-intercept form, yeah, look it up. And it's amazing because it's literally right at, the end of your arm typically because it's in your hand with your phone. Finding slope, finding intercepts will be some of the work that's in Chapter 3, I believe. That's part of your Check Your Understanding for today. Finding slope, if they give you 2 points. There's my 2 points, and then my slope was, which we did on the previous page. Oop, I did that. It's y2 minus y1 over x2 minus x1. I typically try to do my y's script, cursive, so that way it's very definitely not a y. Otherwise, sometimes I'll do a y like this, or I'll do a y really quickly like that, and they look the same. So as to not create confusion. And then finding intercepts, there will be examples where, so if I take a couple points here, let's just do a couple. If those are my points, I'm going to quickly find the slope. The slope will be y2 minus y1, 4 minus 3, x2 minus x1, negative 1 minus 2. So that will be 1 over negative 3. So my slope is negative 1/3. So there's my slope-intercept form. How do I use that? I can then take either of the points that I was given up here and plug it in for x and y. I'm going to choose this one only because it's just not negative numbers. I like to work with positive numbers when I can. So I'm going to go ahead and take this 2, put it in for that x, this 3, put it in for that y. I will have 3 equals negative 1/3 times 2 plus b. 3 equals negative 2/3 plus b. And then the last step of solving an algebraic equation is move everything to the other side by adding 2/3. So it'll be 3 and 2/3 equals b. And that would be my intercept if I'm given 2 points. Functions. Functions, oftentimes in a book you'll see it written, and it's a good way to think about it. If I have this set of data and I have this set of data, and I have this point, I have multiple points here, and I could call them like A, B, C. I could give them names and things like that. Or maybe it's a coordinate if we're talking about our Cartesian coordinate system. And then I have, and this is from data set 1, this will be data set 2. And if I have a bunch of points over here in data set 2, well, like alpha, beta, we'll go with delta, we'll do the other delta, it doesn't really matter, something like that. If this data point B maps only to that data point and no other data points, and every point that's in the left side only has, now these could go to the same one. I could even have A go to this same one here. As long as every data point here only goes to one point over there, it is considered a function. The minute if I have B also goes to this one, I did it in red there because that's to tell me, oh, that red made something wrong. Now it's not a function because B maps to 2 different points, and I can't have that for it to be considered a function. You may have learned, shrink that up and move that up here, in a Cartesian coordinate system, an example of a function would be something like a cubed function, where that goes down forever. That would be considered a function. And the reason why is for every x value, so if I'm here at x equals 1, and I look at the graph, there is only one place that that graph touches that point. Even if I'm way over here, it goes all the way up here, if it would extend up, and it goes through that point, but there's only one point where it touches the graph. That makes it a function. If I have something like a cube root function, No, better than that. Let's go square root function. A square root function could look like this. So it looks like a parabola, but it's turned on its side. Now, if I'm over at 4, I go up and the graph has a value here and it has a value there. A value at 2 different points means, we'll go blue, here and here, 2 points. If there's 2 points, that means this is no longer a function. All right? We call it the vertical line test. If I did a vertical line and it crosses the graph more than once, then it's not a function. All right? A far more sophisticated definition is for every x value, there exists one and only one y value. But that's a function. Vertical and horizontal lines. This could be refresher, maybe it's not. If I have a horizontal line, think but don't answer. Does anybody know what the slope of a horizontal line is? So since a going up line has positive slope and a going down line has negative slope, if it's neither going up nor going down, it's 0 because 0 is the number that's in between positive and negative. Where people get a little tripped up is now if I have a vertical line and I got to figure out what's the slope of that line. What do you think? Yeah. It is undefined. It doesn't exist. And let's say here's, so if I say this is 3, if I take 2 points on that line, 3, 1, and 3, 2. And if I do the slope function, or the slope equation, I should say, y2, 1, minus y1, 2, those are the y coordinates, over 3 minus 3, so then I would have negative 1 over 0. And then if you don't remember this, many people will say, well, that's 0, and that would be wrong. Because what you're asking is, how many zeros go into 1? Or how many zeros go into negative 1? And the answer is all of them. Every 0 that exists in the universe will go into 1. How much space is left over? All of the space is left over. The full 1 is still completely there. It cannot go in there. So really, this is an infinite value, which makes it undefined because we cannot define infinity. You can't have an infinite slope. Infinity doesn't exist, so we just say it's undefined. A vertical line has an infinite slope. So vertical versus horizontal. In terms of equations, this yellow line equation will be x equals 3. How do we know that? Because every point on that line, the x value is 3. 3 comma negative 5. 3 comma 4, or whatever it is going up. Every value on that is x equals, because every value is x. So its equation is x equals 3. What is the y value? Who cares? X equals 3. The blue line, my equation there will be y equals, it appears also to be 3. Y equals 3. And if I had to write that in slope-intercept form, it's y equals 0x plus 3, because the slope is 0. Perpendicular and parallel, we just covered that. But what if, let's do this. Take a moment, look at that graph, and see if you can figure out the slope of that graph. All right. So the words that we're thinking of in a graph like this, rise over run. And if we look at the graph here, the 2 data points, to get from here to there, I'm going from 0 up to 4. So that's my rise. And then my run, and again, going up is positive. If I'm going down, it's negative. I'm going up is positive. I go to the right from here over. That's also going over 2 because that's a 2. My slope is 2. The question I have for you now is, if I wanted to do a line perpendicular to that one, what must the slope be? So here's a matter of like, well, if I could try to draw a perpendicular line, does that look perpendicular? Yeah. It kind of does. It has to be negative. Has to be negative. The slope has to be negative because the other one's positive. So no matter if this one's positive, this one down here has to be negative.
Just do negative 4 over negative 2?
It would be negative 4 over negative 2. Well, it would be, put it this way. If it has to be negative, I'm just going to take these numbers and flip them. But not negative over negative. That would be a positive. I take the numbers and flip them and make the other one negative. All right? And the words, again, if you've heard from past mathematicians or past math teachers, they probably or possibly use the words, the negative reciprocal. Simply means if 2 is my slope of the one line, which is as a fraction 2 over 1, the perpendicular line will take the reciprocal of 2 over 1, which is 1/2, right, 2/4. And if this is positive, I make it negative. If this is negative, then I make it positive. So they have to be opposite signs, and they're flipped fractions for perpendicular lines. All right, linear or not, slope and intercepts, function or not, and then we're going to graph it. I'm going to do this quickly. Is it linear? Yes, it's linear. How do I know it's linear? The highest power of the x and the y are 1. The y is to a first power, the x is to a first power. This is a linear equation. What are my slope and intercepts? I'm going to quick convert this into slope-intercept form by subtracting 6x from both sides of my equation. Negative 4y equals negative 6x plus 10. Going to divide by negative 4. Negative 4 over negative 4 reduces to 1. 6 over 4, both are negative, so it'll be positive, 3/2. 10 over 4, negative 4 is negative, so it'll be negative 5/2. So now I know that my y-intercept, x, y, 1, 2, 3, 1, 2. My y-intercept is negative 5/2, which is negative 2.5. Down here. My slope is 3/2, so that's going positive, positive, so up 3. 1, 2, 3 over 2, right there. Can graph that line. Again, that was quick. Supposed to be semi-review, so if you need to go back, rewatch this again, rewatch it again, rewatch it again. Look on Khan Academy, there's a ton of resources there as well. Linear or not? This is not linear because x has a power. Slope and intercepts. Well, if it's not linear, it doesn't have slope. But we can find intercepts. In other words, where on the xy axis does it equal 0? Where does it cross? First thing I did is I factored an x out of both of them. This equals y. And I'm wondering, when does y equal 0? Well, I have two things being multiplied. This is multiplying by this whole thing here. Give me two numbers that multiply to 0. 0 and 1, 0 and 2, 0 and anything. So in order to multiply to get to 0, either this here has to be 0 or this has to be 0. What makes that 0? Well, 0 does. What makes this 0? When is x squared minus 4 equal to 0? Well, then I add 4 to both sides. X squared equals 4. Take the inverse of squaring, that's square rooting. X equals plus or minus 2. We'll spend some more time on the squares and stuff later as well, in case you didn't remember that it's either plus or minus, because 2 times 2 is 4. Negative 2 times negative 2, also 4. So where are my intercepts? We're actually finding our x-intercepts at 0, 2, and negative 2. And this graph looks like this when you graph it. And that's how you do Desmos. Like, when should we use Desmos? When you don't know what to do with the graph. Not a linear thing. All right, for this one, a line parallel. So I need to get this into slope-intercept form. Subtract 1/2 x from both sides, which I just did. Change it to y equals 1/2 x minus 4. And then I'll use that slope and that point with point-slope form, which we're not going to have time for today. And then this is on Canvas. These are your check your understanding problems for this chapter. So as always, I don't have an office. I don't have a phone number. If you want to reach out and set up a time to go through problems with me, catching up on things, I'm totally fine with that. Just sit and do some, oh gosh, you want to sit down and do scripture. I'm good with that too. But that's it for today. Until next time.